In this video, we're going to go over combinations for problems 28 to 30. So problem 28, 5 members of the Spirit Club have volunteered for the club's governing board. These members are Al, Barbara, Carl, Dale, and Ernie. The club members will select 3 of the 5 as board members for next year. One way to do this is to select a president, vice president, and secretary. Another way to elect a governing committee of three where all members would have the same title. So A, how many different lineups of officers are possible? So again, same thing, we could pick a president, a vice president, and a secretary. We have 5, 4, and then 3 options. 5 times 4 times 3 is 60. There's 60 different ways that we could have officers. So if this was Al, Barbara, Carl, that's different than Al, Carl, Barbara. You care what position you have here. Part B, though, says how many different 3-member committees are possible. In this case, it's a good idea to make a list of all the possibilities, which are called combinations. So they're just in a group. ABC and ACB would be the same. So ABC, we just want a group of 3. Al, Barbara, and Carl. That's one group. It doesn't matter whose name you call first, second, or third. They're in a group. Next, we could have Al, Barbara, and Dale. Or we could have Al, Barbara, and Ernie. That's all the groups that could have Al and Barbara in them. We could then have Al, Carl, and Dale, or Al, Carl, and Ernie. Or we could have Al, Dale, and Ernie. So there's 6 ways that Al could be in one of the groups. So I'm going in order. So then I could have Barbara with Carl and Dale, or Barbara with Carl and Ernie. And then I could also choose Barbara, Dale, and Ernie. Going in alphabetical order to make it easy. And then last I could have Carl, Dale, and Ernie. So there's 10 ways here that I could have a group of 3. If I want a president, vice president, and secretary, there's 60 ways. If I just want a group of 3, there's only 10 ways. These are called combinations because order doesn't matter here. So Felicia wants to volunteer for the club governing board. Now how many different lineups are possible? So Felicia wants to make it more difficult. So again, we could have the president, vice president, or secretary. So we have 6 options, 5 options, and then 4 options. 6 times 5 times 4 is 120. Alright, now we're going to list them. So we want to know how many ways we can make a committee here. Let's see. I missed one. I missed, just to kind of keep them in order, A, B, E. That should be up there. Whew, that was a lot. So there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are the 10 that have Al in them. But then we keep going. So there's 10 ways that we could have Al in the group. So notice it's this same list, but we're adding more to it. So we could have just said those 10 plus more. We could have BCD, BCE, BCF, BDE, BDF, or BEF, CDE, C, D, F, C, E, F, and D, E, F. So 10, 6, 3, and 1, 20 ways here. So again, for both of these, order doesn't matter. You're in a group of 3, it doesn't matter as long as you're in that group. So down here, part D then, it's the same kind of idea. It says, so now since there's more people, they decide to add another member. They can either have a group of 4 for the committee, or they could also add a treasurer to the list of officers. And we would want to know how many different ways we could do that. The list here is actually shorter. So we could have president, vice president, secretary, and treasurer. So we have 6 options, 5, 4, and 3. So 360. Or if we list them, we'd have 4 things in our list now. Alright, A, B, C, D. A, B, C, E. A, B, C, F. A, C, D. Nope. A, B, D, E. A, B, D, F. A, B, E, F. So far, there's all the ways I could have A and B. Let's see. A, C, D, E. A, C, D, F. A, C, E, F. A, D, E, F. B, C, D, E. B, C, D, F. B, D, E, F. Oh. B, C, E, F. That should really be right there if I'm going in alphabetical order. It doesn't say you have to. I think it makes it a little bit easier. And C, D, E, F. So here, that's all of them. There's only a total of 15. Okay, so we want to know how these compare. Let me get the exact wording. Compare the results you got for each part when they were a permutation and a combination. So again, permutation, order matters. Combination, order doesn't matter. So this one was times 6, or divided by 6 if we went that way. 120 to 20 was also times 6. 15 to 360 is multiplied by 24. So we were comparing these combinations and permutations. So for a combination, when order doesn't matter, you have less choices. But now we want to figure out, so let me write that down first. So for combinations, order doesn't matter. Sorry, you can't see it. All right, 1229. Combinations, order doesn't matter, and you can't repeat. Remember, for a permutation, order does matter. Combinations here, order doesn't matter. You're in a group. Think about like a combination pizza. You don't care if they put the onions or bell peppers or pepperoni on first, as long as it's all there. Order doesn't matter. But to figure out how to come up with this, let's see. I'll just give it to you. It's a little bit tricky. So this we write as NCR. We read this as N choose R. It's still N objects choosing R of them. Basically, how many things are we picking for this group? These are like groups. This is N factorial over N minus R factorial with another R factorial in the denominator. So this 24 here was another 4 factorial that we were dividing by. This 6 here was 3 factorial. This 6 here was 3 factorial. We were making 3 decisions, making 3 decisions, making 4 decisions. So it's almost the same as a permutation, but we have another R factorial in the denominator. So again, memorize that, write it down, have it for your final. And then 12-30, I'll just do it right here. It says, use your calculate to calculate 20, choose 4. So I want to use the calculator, but I also want to show you guys what this means. So this is 20 factorial over, that's a factorial, 20 minus 4 factorial and 4 factorial. So it's 20 factorial over 16 factorial times 4 factorial. These two terms in the denominator are always going to add up to your numerator. And the reason this extra piece is there is because we're taking out the duplicates. Because order doesn't matter here. ABC and BCA, that's the same group. For a combination, you don't count that twice. So on your calculator, again, math, let me focus, go over to probability, down to the third one. So 20, choose 4 is 4,845. So it's very similar to the permutation, you just have another part in the denominator because order doesn't matter. So you are counting all the duplicates, or you're taking out all the duplicates for your groups.